So just a few examples. I mean, this is one of change between years. So this is survey data from Ethiopia. 2 years, 2010. This is one of our worst stripe rust epidemics in recent history in Ethiopia. So you can see here, all of this area, 600,000 hectares were affected by stripe rust in this epidemic. It was a really big epidemic. 2013, we're basically, you can see pretty much the same survey coverage, but this year we'd got stripe rust under control, largely due to the promotion of resistant cultivars. Yeah, we still had pockets, but basically the core wheat areas, we'd managed to get it under control. But you can clearly see, you can pick up the differences from the survey data. So putting the data together, then adding value. I mean, we're now getting some useful tools. So we've got this toolbox, and what basically any of you, I can give you access to this system. Yeah, some of you, or in this room at least, have access, and there you can go in, you can see your own country data. So you'd see a summary across years, how diseases change, you'll see maps. So again, it's just giving you instant access to information. The spatial statistics for pulling out hotspots. So we can look at the survey information and we can work out, okay, consistently this is where we're finding stem rust, or this is where we're finding yellow rust. So again, that's useful for planning, promotion of resistant cultivar. Where would be the priority areas that you would try and promote those cultivars? Or where would you prioritize your control efforts? And then wind models. So these are just simple, trajectory models. So this one here, I mean, Robert talked in a previous lecture about, they think at least 3 times that stem rust probably came from Africa to Australia. Well, this is how the winds move, yeah? It's very feasible from what the models are saying, that something here could end up in the wheat fields in Australia, just blowing by the wind. We're getting a bit more advanced on the wind stuff. So this is data we're working with Cambridge University and the UK Met Office with some very advanced particle dispersal models. So this is just an example from the stem rust epidemics in Ethiopia. So this was like the core of the epidemic. These green dots are where the survey found the really highly infected stem rust fields. And this is basically the spore plume, where the model is saying the spores would move. Yeah. So what you can see here is that there's a very good fit between what the field surveys are telling us where the disease is, where the epidemic was, and what the model is saying where the spores would move. So we're getting increasing confidence in what the models can tell us about spore dispersal. So, just to summarize all of this, I mean, I don't think there's anything new here for any of you. Their surveys are the starting point, really. These are the foundation for, your surveillance, your monitoring. Informative of what's actually happening in farmers' fields, and that's what we should be all interested in. Their basis for change detection. We're getting some new tools that can help us, and we can also add a lot more value to that raw survey data. But we need it, and we need it in a timely manner, and we need to have the data consolidated, well managed, and then that we can give you extra information on top.